Simultaneous equations by elimination. Our aim when we solve algebraically for a pair of simultaneous equations is to get our equation down to one pronumeral so that we can solve the equation. Obviously here, elimination is referring to eliminating one of those variables. We do this by either adding the two equations together or subtracting one equation from the other. This is usually used when we've got equations in the form something x plus or minus something y equals a number. That is the form ax plus by equals d, rather than one equation being in terms of x or in terms of y. In order to eliminate a variable by adding or subtracting, we need one of the variables to have the same coefficient in both equations. The sign doesn't matter, plus or minus, whatever, but the number in front of the letter, that is 1 for the y's here, means that we can cancel these out. If we didn't have either of them with the same number in front, the same coefficient, we could multiply one or both equations by a constant, so we did have that, and I'll show you that example next. Now, we set up our equations as we normally would. We label them equation 1 and equation 2. And we do just make sure that our x's line up and our y's line up and our equals and our constants all line up. That's why we want it to be in this form to use this. Now our big question is, am I going to add or subtract? And you do what you need to do to cancel out these two. If you imagined for a moment that that was plus, then two positive y's, y and y, if I added those, y plus y, I would get 2y. I wouldn't have cancelled it out. If I subtracted y minus y, that would be 0. I would have cancelled it out. So if your two that you're cancelling out have the same sign, you subtract. Whereas here when I've got different signs, y minus y, if I subtracted, that would be y plus y. I'd get 2y, that's no use. But if I add them, y plus negative y, that's y minus y, it's 0, they cancel out. So I add when the signs are different. So I state what I'm going to do. I am going to do equation 1 plus equation 2. X plus 3x is 4x, y plus negative y cancels out. Put down your equal sign, 6 plus 10 is 16. I've eliminated the y. Now I can solve this for x. And from here, this solution is exactly the same as it would be for substitution. Substitute that back into one of the equations. Choose the easy one. So I've got x plus y equals 6, 4 plus y equals 6, y equals 2. Give your solution. Now when you give a solution, I've been giving them as x equals this, y equals that. You can say therefore solution is, and give that as the coordinates. That's fine as well, just a different way of giving your solution. Remember, of course, you do your check. Excuse the bell there, I hope it doesn't get a little bit noisy. You've checked that it works for 1, equation 2, substitute your values in. That is correct. Your solution is correct. Sorry about the extra noise, I don't know if that's coming through the microphone. So to solve this by elimination, you look at the coefficients and you see, actually, I do not have a set that's the same. You still start by writing equation 1 and equation 2. Now, If you chose to eliminate the x's, you'd have to get these both to be the lowest common multiple, which is 15. You'd have to multiply this equation by 5 and this equation by 3. You could do it, it's no fun. Instead, you've got 1 and 2, we can just multiply this equation by 2 to get the y's. You say what you're doing. I am going to do equation 1 times 2. That will become a new equation, which is now called equation 3. Y times 2, negative 3x times 2. Whoops, that's an equal sign, I'm sorry. And 1 times 2 is 2. Now I have equation 2 and 3 that I can use for elimination. Because the signs are the same, I'm going to subtract. Just a little point, it will work either way. You're better off setting up your subtraction so I do 2 minus 3 because I've got a larger number here, so I'll end up with a positive number. If I did 3 minus 2, I'd be playing with negatives a bit more. And I say what I'm doing. I'm going to do equation 2 minus equation 3. 2y minus 2y cancels out. 5x minus negative 6x is 5x plus 6x, which is 11x. Put down your equals sign. And 13 minus 2, oh look, that's 11. Didn't that work out nicely? Incidentally, at this level, if it doesn't work out, like if it works out as a really ugly fraction or decimal or something, you've probably done something wrong. We mostly give you systems of equations or simultaneous equations where they're pretty nice and friendly. If it comes out really nasty, like if it was 11x equals 13 or something like that, you might want to be really careful with your substitution check to make sure you haven't screwed up something somewhere. Anyway, this says x is 1. As you know, substitute x equals 1 into, we want to find y. This one looks a bit easier. But, you know, if you chose the difficult one, it would still work. You've got to substitute it in anyway. You can also substitute it into 3 if 3 is any better, but I'm not sure why you would. Y minus 3x equals 1. So y minus 3 times 1 equals 1. Y equals, add 3 to both sides, I have 4. Therefore, x is 1, y is 4. We just checked it for 1, but we do our check for equation 2. Substitute those in. 2 times 4 plus 5 times 1 is 13. 8 plus 5 is 13. Yes, you're correct. So the big thing with your simultaneous equations by elimination, you must have your x's and y's and equal signs lining up. You usually want to be in the form ax plus by equals d. You'd have to rearrange if you won't. And if you have to rearrange that much, chances are you wanted to substitute instead of using elimination. Know whether you want to add or subtract and follow those really careful steps that you must have beautiful working down the page. Do not get creative. Do not decide you're going to do something else. State your equations. Say what you're doing. Substitute your found variable into an equation. State your solution and check.